hello everyone, I'm Jacek and I'm Java developer. I will try to tell you something about the Testcontainers library. So yeah, as I was saying, I will try to give you a brief introduction into Testcontainers library. So first thing first, I will tell a few words about the agenda I set for this presentation. So it is as follows. So I strongly believe that an introduction of the new tool must be some kind of response to a need, and the need is usually created by a problem, some kind of problem we want to solve or we want to improve some area. So during this presentation, we will establish that problem. So the we will try to um, we will try to make sure that the Testcontainers library is a good tool for solving this problem or helping us out with this problem. We will talk a little bit why the problem is the problem we are trying to solve and how do we want to solve it using Testcontainers ideally, yeah, because it's our main man today. And also about eventual benefits, if there are such, of the Testcontainers solution. So yeah, what's the problem that we will try to solve? So I think, and I'm almost pretty sure that all of us were in a place where we develop an application, we write a bunch of unit tests, maybe good ones, maybe perfect ones, and everything seems to be perfect. We launch the tests and everything is green. Yeah, it's our small developers paradise where we're not so often. Yeah, so our green paradise, and these are those unique moments of joy in every developer's life when the tests are green. Yeah, so let's say that we have about 80% of the production code covered by unit tests. We run the application, and to be honest, different things may actually happen. But we have good unit test coverage, right? We have those magical 80%. So the unit tests are enough. And probably, yeah, but, and thanks to Mateusz Mlich, who showed this meme on some presentation, it is a perfect visual representation of our problem. So we have automatic doors and automatic gate, which works, every single of them work perfectly fine, but together they are not working completely correctly. Yes? So we see that when the gate is closing, the doors are opening. So something is definitely wrong here. And it happened because in unit test, we don't cover the interaction between different components or different services. So why do we have such problems? And the unit tests are great. Yeah, I hope that we all can agree on that. So they are this basic thing which is a first line of our defense against bugs and some unexpected behaviors and sneaky corner cases. And because they focus on units, they isolate those code units, and thanks to that, they are very, very fast. So we're able to run hundreds of tests in a split second. Yeah, so that's really nice. And they are also very helpful when it comes to debugging small portions of the code. Yeah, so we've all been there. We've all written our first Hello World application or some simple calculators, and we don't necessarily want to launch the whole application every single time. And thanks to the tests, we can test the part of our code. So like, for example, one method. So that's perfect, yeah. However, the unit tests in general are not perfect, yeah. They have their limitations. So their greatest strength, which is the isolated focus on the unit of code, may become their bigger limitations, which we've seen already on the previous example of our doors. Yes, so they were working correctly, but together they weren't. So it's some kind of integration blindness, which we need to balance somehow with something else. And unit tests may also give us the false feeling of security. So our application is immortal, right? And we've seen that simple integration can destroy the whole thing. So in our complex modern applications, I think that unit tests are not sufficient anymore. We need something complementary to unit tests, which will balance out unit test disadvantages. Yeah. So we need some kind of integration testing, ideally, or something like that. Unit test doesn't give us the production-like environment, so they are perfect for checking the portion of the code, but they are not perfect and not reliable on their own only. Yes, so I was talking about the consequences already, I guess, but for me the biggest problem is this first one, the undetected integration problems, which may appear everywhere, yeah, on every production or staging environment. Because of that, we're losing time to figure out what's wrong. We're losing time to set the correct, I don't know, URLs to databases or something like that. And maybe we had a typo, yeah, and we haven't spotted it earlier. And we're wasting our time on constantly deploying the applications a few times to solve one simple issue. And yeah, in general, I think that it leads to some kind of reduced confidence in our own code quality. So it will eventually lead to a point where we're a little bit scared of touching some area of our application, and it shouldn't be the case, especially if we have tools which will help us prevent that. So yeah, how can we solve those problems? So I've already used the magic word, the word integration testing. So I think that this answer is pretty obvious, and we should use integration testing, and we all know that. So these integration tests are this complementary part of the unit of the testing world, which I think we need to have a robust and reliable application. Yeah. So what are those integration tests? So they are mainly designed to validate if different parts of the system are working together as intended. So their greatest benefit is this one, their testing collaboration between different parts. And they can emulate, if configured properly, production-like environment on our local machine. So again, we'll be able to debug a portion of our code, just like with unit tests, of course, with some overhead, but not so big. And we still can spot the issues very early on early stages of our development. But they are also not perfect as every tool, so they have much slower execution time. They have Yeah, we can run a bunch of unit tests in split seconds. Yeah, so in a few seconds we can run thousands of them. It's not the case in integration tests because we need to set up the whole environment. Yeah, so they cost us something. They cost us the time, and we all know that as developers we don't like to wait for things to happen, and we want them to be pretty quickly. Yeah, pretty quick. Uh, there's also maintenance overhead. So in general, you will have more classes to maintain. You will have more test cases to maintain, and you need your team to understand the testing framework. So it also gives some kind of overhead to your engineers that they must know the tool and use it properly. And they may also have complex setup, but it depends on our application. In microservices world, where I'm from, I would say I used like 3 or 4 dependencies max. So it's not so much, but it also is enough to give you a complex problem to solve, yeah, to test. And as a response to those needs, developers from Atomic Jar provided a solution named as Testcontainers. So as they say on their webpage, which I highly recommend you to visit, they say that Testcontainers is open source framework for providing throwaway, lightweight instances of databases, message brokers, web browsers, or just anything that can run in a Docker container. So literally, from my experience, if you can provide Docker image, you can use Testcontainers library thanks to the generic container which they provide and which I will describe in a minute. But you can even build your own Docker image for the testing purposes. So that's great. And the generic container is like the central, most basic unit of their library. So yeah, Testcontainers have some key features and benefits, and here are some of them. So the first three, I guess, are the most important. So we have container orchestration. So we literally don't have to do anything, almost anything, because they're automated the whole process so much, and they're still developing cool features which help us automate all the process. So they took care about the provisioning, management, and tear down of containers. So we don't have to manually start the containers for our applications like it is in the, let's say, typical case when we run Docker Compose up or something like that. No, we don't have to do that here. We have it everything configured in our code within just a few lines of code and few annotations or few properties specified in your application context. And what's maybe even more important, they give us possibility to have reproducible environments with real dependencies. So if we have Postgres 16 on production, we can have our tests operating on Postgres 16. There's no problem. We have older version, we can specify older version. Everything is configurable. And that's why I think it's so reliable to use this tool, this feature. They also took care about the isolation. So in general, containers are isolated, so the tests are not interfered one by another. But we can control this behavior, and I will show you one common example where you can make your tests faster and reuse the containers. And they allow parallel testing. However, I'm not an expert here. To be honest, I've never used that, but I will for sure go a little bit deeper here to speed up the whole integration testing process, because it takes some time. It's not like unit tests. It's much longer depending on the number of containers you're using and the configuration. So for now, Testcontainer supports for following languages. So the main ones are like Java, Go, Python, Rust, Ruby, and so on. I'm not pretty sure if Atomic Jar is responsible for maintenance of every single one of them. However, the communities are so big right now that I think you will not have any problem finding solutions on Stack Overflow or some other on some other pages. So they are commonly used to nowadays, and in Java world, I think that you all heard about Spring Boot, yes? So it's the main framework for Java, at least in Poland, as I heard, we love Spring Boot, and they provide integration with Testcontainer, and they improve this integration constantly. So yeah, I told you that the basic unit of Testcontainers is generic container. So it's just a simple container which exposes to you some data and gets from you some information, like the Docker image you want to use. So here in this example, we can see that we're using generic container for Redis, so probably some cache or as a database. I don't know. And in Spring Boot, the whole configuration looks almost or more or less like this. So we have a few lines of code, and our Redis is ready for the traffic. Yeah, so we can send data there, we can get the data from there, and so on. So just a few lines of code gives us possibility to test our Redis, our application along with Redis. However, there's something more. There is much more than generic containers. So Testcontainer creators provides a lot of different modules, and they provide specific containers for different types of services. So I guess that there is more SQL databases named that I know that are supported. So the main ones, of course, like Postgres or MS SQL is also supported. They support Kafka, which is really nice, RabbitMQ, and other stuff. And remember that in case you don't have the specific container, you can still provide the generic one, like with Redis, because Redis doesn't have its own container. I don't know why, maybe it's too simple and they skip that. But yeah, it's possible to literally put everything into such container. You just need to specify the image and some parameters. But here in this example, we have Postgres container where we specify the version, and we have a bunch of useful methods which are not exposed via the generic container API. So like with database name, with username, and with password. And it's really easy and convenient thing to use. Yeah, so they have pretty much everything I always needed in those APIs. So yeah, if we use specific containers, specialized containers, we're good to go. So yeah, as I said, we can do everything we need with generic container. It gives us enough information to make sure that our application will know where the container and the service inside the container are, so we can set them up together to work together. Okay, and few words about the topic that I'm definitely not master of. So CI/CD pipeline, it's also possible to configure CI/CD pipelines in a way that test containers tests work fine. So in my previous project, we were using GCP and GCP triggers, so Google solution, and we were able to configure it. Here you have a link to the test container documentation where they provide some solutions for popular CI tools like GitLab CI, Bitbucket pipelines, and few others. So it's possible to run your test containers tests within the CI/CD pipeline. There's no big problem with that. It will for sure require some configuration, additional configuration. But yeah, in general, it's possible, and it's very, very good. Yeah, because we always want to include every step in our CI/CD pipelines, especially something like testing. So yeah. And to be honest, recently I discovered the Testcontainers desktop app, and I want to tell something more about it. So it's like a small application running in our background, which allows us to do some cool stuff, something like freezing containers shutdown. So if we want to debug some containers, we can freeze their shutdown, and we will have them running after our tests. To be honest, I've never know about this application until now, so I've never used it, but it will be very useful because I remember that I had to reconnect to some containers, and if the container is fresh every time, and the default behavior is that you have a random port. So yeah, it was a little bit painful to check the port and connect to a specific host and port all the time. So it may help out. They also created something like Testcontainers Cloud, which is really awesome feature, but unfortunately, I guess it's only free for solo developers. So it's like they give us a little bit of playground where we have 300 minutes per month for free. And thanks to that, you don't need actually anything. You don't need Docker environment on your local machine. Everything is delegated to the cloud. You just need a free account there. So I highly recommend you to play with it a little bit. I will for sure. And the next one is the experimental feature, which will be a nice tool, I guess. It's reusable containers. So the default behavior is that when the tests completes, test containers, or we, depending on on our solution, we should close the containers. Yeah, we should shut them down. So with reusable containers, it will be possible to keep those containers alive and reuse them in future tests. Yeah, so the most costful process in integration testing using Testcontainers library is definitely setting up the containers. So it takes like a few or more seconds, depending on how much of the containers you use and on your configuration, because you can also run them in parallel. But anyway, it costs you a few seconds. So when you're developing, it would be nice to have something like reusable containers just to avoid those just to avoid losing these few seconds every single time we're running a test. Okay, so as I'm Java developer, I will try to present you some examples using Java and Spring Boot application. So let me just share my screen again, but different tab. Okay, I guess I have everything configured here. Tell me if you see my screen, because I know that it can be a little bit tricky.
Yes, we can see it. We can see it.
Okay, nice. Thank you. So yeah, I've prepared for the purpose of this presentation very simple microservice, which has some API, so you can play with it. I will also include the Postman collection for it, so you don't have to create it from scratch. So basically, we just have a controller which accepts some data if we perform post or retrieve some data if we want to get something. And the heart of that is the domain with the service. So we will add something more here later in this method, one of these methods. But for now, the application is really simple and it just connects to a database. So in this service, we just have the references to repositories, which will be injected here by Spring. And basically running this method, for example, getAll should list all of our articles within the database. So nothing fancy, just to start playing with something. Okay. In the application YAML, which is the source of configuration properties in Spring Boot, I have included the URL to my database source. So if you want to play it without Testcontainers, you have also Docker Compose here. So it should work out of the box. If we run it and we can try this one out, I will just make sure that my Windows, my Linux is running. So give me a second. Nothing is here. Okay. So we'll just see if the application is working. So right now, I will set up all the required dependencies as usually. So with Docker Compose, we will run the application and we'll see if something will be retrieved just to make sure that we have everything connected. Okay, so I have predefined set of data with the articles which have only the ID, author, and some content. So as I said, to keep things simple, yeah. I will include this collection in my materials, so we will be able to start without writing everything from scratch. So for example, if we want to create the article, we'll get ID, we can retrieve it by ID, we can update, we can also delete it. So we can delete it if we want to check if it works. And it should work. Okay, however, I imagine that you can imagine this type of testing is not necessarily the most enjoyable if you have to run everything and switch the apps and so on. So for that purpose, we have test containers here. So to add them, you just need a few dependencies. So because we're playing with Spring Boot and we have pretty good integration, they provide, I included it also in Maven. We have some Postgres test containers, so it will give us possibility to look for the specific container. Yes, so to Postgres container, and we also have test containers JUnit, JUpiter dependency, which will allow us to use some cool annotations which will help us with lifecycle management. Okay, so I will close everything and we'll start from this example. So yeah, what happens here? We have a Spring Boot test, so it's Spring related, but almost everything else is just similar in concepts, I think, in every programming language. So here we have two annotations for in Java, in test containers for Java world, very important. So it's test containers and containers annotations. So those two guys will allow us to skip the lifecycle management completely. So test containers will take care of setting up the container and shutting it down. And as you see here, we have this Postgres container, which allow us to specify initialization script via its API. Yes, so we're specifying Docker image here, initialization script here, which I will show you in a second. So we're just creating a table and inserting some data just to make sure that we have something to start. Yeah. So it's nothing complex. And in Spring Boot, until version 3, we had to do something like that. So use annotation dynamic property source and put some things in the registry. So our application must know where is the Postgres. Yes, so we need to specify URL. I guess it will be really similar in other languages and frameworks. We have to specify username and password to connect to it. And thanks to the fact that we have Postgres container, we can use predefined method for that. So for example, we have get JDBC URL here, which will return us the JDBC URL we need to specify to connect Spring context with this specific Postgres database. Yeah, we can also get the username and get password, so we don't have to hard code anything. Everything can be dynamically taken from this container. It's worth mentioning that specific containers have generally some default behavior. So for example, we don't specify here the test database name, the username and the password. So everything is set to test. And those values will be injected here. Yeah. So yeah, maybe let's run it and we'll see what will happen in a console. Our test should be green. Okay. So first, yeah, if we have our environment well connected, what I mean by that is if you're using Windows subsystem for Linux, I had little bit troubles configuring that, but it's possible to configure Docker in such a way that test containers can see it. So we can see from the logs here that the server version is 23rd version, API version, and operating system is my Ubuntu system, and the total memory. So if you remember that, I will go back to that later when we switch to the cloud version. Yeah, so basically at the very beginning, test containers set up their test containers, I would say main container, named like that. And then they are trying to start the Postgres container. Yeah. So here we see in this particular log that the container with Postgres is started and the JDBC we can use to connect to this container is like this one. So this is the JDBC URL we're specifying here. We're taking from the container and we're letting Spring know where it should trigger all the calls to a database. Yeah, and we can see here that we have some database scripts found. So yeah, everything worked as expected. If we want some more logs, we can always specify the log consumer. This is another method available via the API. So we'll see what's different here. It will be a bunch of new logs, but we will see something more. Yeah, so we'll see that it has the information it had previously, but here we have standard output from the container itself. And we can see here that the create database, and somewhere here we should have some information about the creation from the script, or maybe not. Yeah, but we still see those logs, so we're pretty sure that our database contains some predefined data. Yeah. So this is like the very basic example where we have our application and just the database. So as Java developers, we generally don't like this part, and Spring from version 3 made it easier than that. So we don't have to rely on our strings we place here. So I can't count how many times I made a typo and I didn't know what's wrong. And what Spring Boot provided is the service connection interface. So it's really nice tool. If you're Java developer, switch to Spring Boot 3 or newer. What it does, it basically does this thing for us for some containers. So from what I know, it's not ready for every type of container, but for most common ones like Postgres, it's ready. So if we run the test, we should still see the following result. So I mean, all our tests should be green. And if we comment that out and we don't specify any information, the tests should fail. I heard lately that you shouldn't, oh no, you shouldn't trust the test which is always green. So yeah, I have some configuration, maybe it's this one, but I'm not pretty sure what happened. Let me check let me remove the containers and see now. Okay. I will be surprised if it works. Oh yeah. So our old containers, I mean, which we set up manually, came into play. Yes, so we don't have so much time, so I will speed up a little bit. So basically, you have to remember that you need to create the container and you need to somehow put the information you need in your application to your application. So in Spring, we do it like this, or with this new annotation. Okay, it's also a Java trick. I'm not sure if it's in other languages, but here I don't have any container defined. We will check if I have something here. I don't. So this test should fail, yeah? But what will actually happen is we set up container in very convenient way. So in application properties for tests, I specified such string. So if you're Java developer, it may be useful. So it contains every information Spring needs to connect to a test container. So like the dialect, version of Docker image, name of the database, initialization script, and so on. So it's really cool that they have such feature, but let's move forward. It was just a nice trick. We can also in Java and in Spring Boot specify containers in different places. So if we want to have some configuration class for that, we can also create a bin from this configuration. We can specify everything here we need. And if we include this class, so we import it, it should also work out of the box. We don't have to do anything. I also used service connection here, so Spring automatically knows where to find Postgres. So it's really cool that they added this feature. And now we'll try to see if the reusable containers work. So you need to have your Testcontainers desktop app, and I cannot show you that right now, but there's a Boolean flag, enable reusable containers set to true. And yeah, here there's some small change. We need to manually take control over the life cycle of the container, but it's fairly simple. Every container has its start method, which will set up this container. And because we want to reuse the container, we set additional flag here with this method exposed by the Postgres container API. And we don't close the container anywhere. So if we run it, we'll see what will happen in my Docker environment. Okay, so all the tests passed, and let's see. You see that this container is still here. So we won't find any shutdown related to the container in the logs. Just the Spring context is closing here. So yeah, if we run the same test again, we shouldn't see more Postgres images here, Postgres Dockers here. Yeah, so it seems that it's still using the same. Let's run it one more time. Let's see. The test seems a little bit faster right now. And yeah, this container is still being reused, so the experimental feature they provided also works. Okay, so that's the end of the first part. I want to show you something more. I included the link to these examples in my presentation, but I will also send you in the chat. So these examples are available in our iLearn GitLab. So I hope you have access to that. If not, please write me later. I will send you a zip or something. We'll figure that out. And you will see a few branches here. So this was the typical example because I feel that database is the most common thing we want to test. And I want to add something more. So we'll check out to the other branch. So what I've added here is I added a simple publisher. So I use PubSub here just to show you how it works. So yeah, in this point, when we're trying to create the article and after we save it, we should publish a new message with the saved ID and author. So we'll see how to handle it in our test. So yeah, I have a simple test case here again. And again, we have Spring Boot tests since we're in Spring Boot Java. We have, again, test containers annotations. One of them is Postgres with service annotations, so we know that Spring will find our Postgres. And we have PubSub emulator. And here I'm not using the official Docker image, because we found another one which is more convenient to use, mainly because you can specify the environment variables, and it will create topics and subscriptions for you for particular project ID. So it's very convenient. And we can see that here we have another exposed method from generic container API. So it's called with env, and we can specify the environment variable here. Just to show you the similarity, if we have Docker Compose, we can do it like that, yeah? So we can do pretty much everything we do in Docker Compose using test containers. We're exposing this port here and injecting some PubSub template just to fetch the data, fetch the message. So we'll see if it works. Here is small advice for Java developers. It's probably included in test containers dependency, the awaitility method. So anytime you have some asynchronous tasks, you can use this library, and it provides convenient API to use when you're waiting for something. Yes, so we will wait here for the PubSub message. And if we start this test, it will take a few seconds. So we have just Postgres and PubSub emulator, and it will take like 10 seconds, I guess. We can check it after the tests are completed and the containers shut it down. Okay, so the test itself lasts 1 second almost, but the whole process started 52:30 and finished 52:41. So it's 10 seconds for just one simple test case. So you need to be careful here, uh, not to overuse new containers, yeah, and to always take care of the configuration of your containers, because it may grow to minutes. And I know it from experience. Some of our microservices in my previous projects uh, were building for like 10 minutes or so. So it was too much simply. Yeah, because we have generic container here, we need to specify, and we specify the emulator host for Google Cloud PubSub. And I hope it will be visible here. Yeah. So I printed the message we received. So it looks like this. It's not perfect. It's ugly, to be honest, but it's just for the purpose of this presentation. So yeah, everything works fine. And what in case if we have like bunch of such tests? Do we have to spin up all the containers again and again? So there's something called singleton pattern in test containers world, and we can achieve it by creating abstract class, which will have some containers defined inside, and we manually have to start them. There's no way to delegate this task for test containers. But when you see the result, it's pretty much great, because we reduce the time to spin up the test. So if we run this folder, so all of those tests, we will see that containers are started just once, and they are reused 3 times. Yeah. So you see that the tests are much faster. Without that, if we had 10 seconds here, we wouldn't be able to get the result in, I guess, 10 seconds. We can check it. So 54, 52, and the end was 55, 02, 54, 52. Yeah, so like in 10 seconds. Yeah, again. Yes, so we reused those predefined containers here in our test classes. Unfortunately, they have to extend it. As we know in Java, we don't like inheritance too much, but it's necessary here. However, uh, there are some solutions to that, but uh, I've never had time to dive deeper, but I've seen that they are doing everything on annotations, so it's possible to avoid inheritance even. Okay, last thing I want to show you, because we're running out of time and I don't want you to uh, be too bored, and I still hope that you will have some questions. So yeah, basically we had a problem with Google Cloud Storage Test Container, and it was mainly related uh, to the image, because the image there is no actual Google Cloud provided Docker image. Yes, so we found something like fake GCS server provided by FSOSA. So whoever this is, he's a lifesaver. It's really awesome, but it has one issue. So uh, when you're reaching the fake GCS server, it returns you a response, and within this HTTP response, you have a particular header which is used further in the Google Cloud libraries, and it was this part. So the HTTP localhost and port were missing, and I was debugging it like a few hours, I think, together uh, to handle it. Fortunately, it's possible to create a container and set up everything. Uh, this image just provides you the possibility to specify some additional flags, like in typical Docker images you can specify some additional stuff, and the external URL is a lifesaver here. So the only pitfall is that we need to know external port before test containers spin up, because the default behavior is that test containers are always run on random port. Yes, so there's also possibility to have the external port configured earlier, and that's why you're able to reach the container, and we are able to set this message, set this header with this predefined HTTP localhost plus port thing. So it works fine if you're looking for something to test GCS Google Cloud Storage. It's a way to go, and it's also included in the whole project, so you won't have problems finding it. Okay, so from the basic stuff, it's pretty much it. I really encourage you to explore the containers, since most of you, I guess, are from DevOps part of our company. So you know probably a lot more about Docker and the stuff you can do with it than I do. So I really encourage you to going deeper into test containers, especially that we have a bunch of languages supported. And yeah, thank you for your attention. I hope you enjoyed the presentation.